Hey folks, so we've been playing this game of finding the x and y that give us the correct, basically the x and y that make both statements true. So they'll give us two equations and we have to find the x and y that make them both true. So let me introduce some terms. The book is really into terms. So when we're dealing with just x and y, we can turn those into lines. So usually what we're trying to figure out is the x and y that make it true, if we graph things, is where the lines would cross. This is just an example. So then they give some fancy vocab. So if lines cross, starts with the letter C, so cross, lines cross, they call lines that cross consistent. And if you only get one answer, then we call it independent. So basically, when we were doing those problems before, solving for x and y, and you get an answer, we could say the system was consistent and independent. Again, why do they do this? Because they're math nerds. Okay. So, and then you may recall when you would try and solve the system, and you'd get something weird like 1 equals 2, or like 0 equals 4, something false. And you'd be like, oh, there is no answer. So what that means if we were to graph things is that the lines ended up being parallel to each other. The lines did not cross. Oh, when they cross, we call that consistent. So if lines don't cross, we probably call that inconsistent. Okay. Sure. vocab. Great. Okay. Now, there's a weird situation that could also happen. So sometimes you start trying to solve things and it ends up being false, and you're like, oh, there is no answer. So graphically, that means you have parallel lines which never cross. So you get no answer. Now, here's the weird case. What if you have, let me draw one line in pink. So here's a line. And then what if the other line happens to lie exactly on top of it? What? So then that means you have an answer, because where lines cross is where there's an answer. Oh, so there's a million answers. So infinite number of answers. Infinite number of answers. Okay. So what would happen mathematically is you'd get something, so not a false statement, but a true statement, something like a 1 equals 1 or a 0 equals 0. Okay. Did these lines cross? Yeah, they cross everywhere. Oh, they cross? Then we can say they're consistent. Sure, they cross. They're consistent. But there isn't just one answer, so they're not independent. They are dependent. Okay, sure. So it is vocab. Okay, so now, oh gosh, we're going to take this into 3 dimensions. So you don't even have to think about things 2-dimensionally, right? Either you get an answer, or you don't get an answer, or you get an infinite number of answers. That's basically the 3 things that can happen. Coincidentally, we could graph things and visualize it. So in 3 dimensions, it's a little bit more complicated because it's flat surfaces, planes, in the 3-dimensional space. So if you go through 4.4 here, they actually have pretty pictures. I'm not going to attempt to draw them, but you can see all the different situations. Like you might have 3 planes that never cross. Okay, no solution. Okay, so let's just go down and do problem number 162. So I'm only going to have you do 4 problems in this section. Just go with it. We're going to learn some tricks later on, but before you learn the tricks, you just have to do a couple of these miserable problems the long way. So yes, these problems are miserable. Prepare yourselves. 162, 2x minus 6y plus z equals 3. 3x minus 4y minus 3z equals 2. Oh gosh, 2x plus 3y minus 2z equals 3. And question A says, hey, is 3, 1, 3 an answer? In other words, if I plug 3, 1, and 3 in for x, y, and z, does it work for all 3 of those? So you want me to plug 3, 1, and 3 into this, into this, into this? Yeah. Okay. Well, that doesn't sound fun. Yeah, I know. Okay. So 2 times 3 minus 6 times 1 plus 3. Let's see if that ends up equaling 3. 6 minus 6 plus 3. 6 minus 6 is 0. That's 3. Okay, so that holds up. Okay, let's try the next one. So the next line, trying to be organized. 3x we said is 3, minus 4, y is 1, minus 3, z are 3. Does that equal 2? Let's see. 3 times 3 is 9, minus 4, minus 9. Did I do that right? 3 times 3, minus 4, minus 9. 9 minus 4 minus 9. That gives us 3 times 3 is 9, minus 4 times 1, minus 4, 3 times 3 is 9, 9 minus 9. So the 9 and the minus 9 go away, gives us negative 4. And that doesn't equal 2. So, no. So this is not a solution. Okay, and then part B, see how fun this is? B says, is 4, 3, 7 a solution? Oh, so you want to plug 4, 3, and 7 into that, and that, and see if they all work out? And if they all work out, then it'll be a solution. Okay, sounds like fun. Okay, how can I save paper? Let's try 4, 3, 7. Oh gosh, is there any shortcut? No? Maybe, I don't know. Okay, so 2, I'm going to plug in that x of 4, minus 6, y is 3, plus 7. 2 times 4 is 8, minus 9, plus 7, negative 1 and 7. That doesn't work. Did I do that right? Am I doing the right problem? 2x minus 6y plus z equals 3. 3x minus 4y minus 3z equals 2. 2x plus 3y minus 3 equals 3. 4, 3, and 7. 4, that gives us 8. Oh, minus 18. Good gosh. 8 minus 18 plus 7? 8 minus 18 is negative 10 plus 7 is negative 3. That doesn't work. That's not 3. I feel like one of them should have been a solution, so that's why I am trying to figure this out. 8 minus 18 plus 7, negative 3. So that's not a solution either. Okay. Well, I'm going to pause my video right here and triple check that I did this right. But basically, that was not a solution, and that was not a solution. Alrighty.